Hi everyone! We're doing lesson 18, which is a review on solving quadratic equations by factoring and then how they relate to x-intercepts. So our learning goals are to review how to solve quadratic equations by factoring, which you should have covered in grade 10, and then also connecting the solutions or roots of quadratic equations to the x-intercepts, also called zeros. So I don't know if you've heard x-intercepts called zeros before. Of the corresponding parabola. So in grade 10, we learned to solve a quadratic equation by factoring. Factoring can be an efficient way to solve a quadratic equation because it's quick. If you're good at factoring, it's quicker than the quadratic formula. However, the factoring method only works for factorable quadratics. If you have your factoring flowchart from the last chapter on rational expressions, grab it and get it out now. You can pause the video. I will find it and also attach it so that if you left your books at school or whatever, you could print it out if it's going to help you. Okay, so the first question. Solve each quadratic equation by factoring. And then there's a little asterisk there. Note, if the quadratic equation is factorable, which all of the ones I'm going to give you are, the roots or solutions will be rational numbers, which are integers or positive and negative fractions. Okay, so we're not going to have the square root or the irrational roots that we had the other day. Okay, so our first quadratic equation is x squared plus 11x plus 30 equals 0. So we've got it in the right format where everything's to the one side. We can't use reverse BEDMAS because the x is in more than one spot. It doesn't look easy to put into vertex form, and we're told to do it by factoring. Which means that on this side then, this should be something that we recognize as one of our methods of factoring. So there's three terms. There's not a common factor, so if you've got your flow chart out, there's three terms, so it's a trinomial. And then you can classify it. It's a simple trinomial because the number in front of the x squared is a 1. So to factor a simple trinomial, you need two numbers that multiply to, in this case, 30, but also add to positive 11. And those numbers are 5 and 6. Okay, so then we're going to factor. So x plus 5 times x plus 6 is equal to 0. So what we've done is we've changed it from adding, three terms adding to equal 0 to two different numbers multiplying together to equal 0. One of those numbers is x plus 5, and one of those numbers is x plus 6. But we can think of it, you can see this off to the side here, as we've changed it into a times b equals 0. Okay, so x plus 5 is an unknown number, x plus 6 is an unknown number. When we multiply them together, our answer is 0. And the only way that can be true is if either this number is 0, meaning this number is 0, or this number is 0. So think about it. Think about any two numbers. If you multiply them together and you get the answer of 0, one or the other of them has to be 0. That's the only way it works. So that leads to the fact that either this number has to be 0 or this number has to be 0 for the equation to be true. And then we have just two little mini grade 9 equations to solve. So get x by itself, subtract 5 on both sides. Subtract 6 on both sides. And these are our two solutions. Okay, and you can write them like that, or you could do like therefore x equals negative 5 and negative 6. Okay? Often just stating them separately is fine as well. Depends on the textbook or the way the answers are given to you. Okay, so there's the thinking behind it, and maybe some of you will think, oh yeah, I remember doing that last year, hopefully. So on to B, x squared plus x minus 20 equals 0. So again, not a common factor. Count the terms, there's 3, so it's a trinomial, it's a simple trinomial, so it means I need to figure out two numbers that multiply to negative 20 and add to positive 1. And those numbers, if you're not sure how to do it, you could always do, okay, so if you're multiplying to a negative, one of your numbers has to be positive and the other negative. And since you're adding to a positive, your bigger number has to be positive. So you could start off doing like 20 and -1, but they don't add up to +1. And then you could try -2 and 10, also doesn't add up to +1. 3 doesn't go in evenly. Then you could try -4 and +5. Oh, there's the right ones, okay? Because they add up to +1. So that means we can factor the left side to give us x plus 5 times x minus 4. And then again, we've put it into this format where two numbers multiplying together gives me 0. Either this number has to be 0 or this number has to be 0. Oops, it's going straight to the answer there. And then subtract 5 on both sides. So one possible solution is that x is -5. Another solution is that x is +4. So there's your two exact solutions again, right? They happen to be integers, but those are my two exact solutions. Okay, C. A little bit trickier because all of the terms are not on the one side. So for a quadratic equation, we do want to do that. So I'm going to subtract 5x on both sides, and these end up being like terms. Also going to subtract 15 on both sides. That's not like, okay? So these are going to be gone, and I'll have equals 0. And then on this side, I'll have x squared plus 3x minus 5x is minus 2x, and then minus 15. So now I've got all the terms onto the left side. And again, there's no common factor amongst the terms on the left side. There's 3 terms, simple trinomial again, which if you're going to use factoring, often it is with a simple trinomial because it's easy to do. Right. And if it's not going to be easy to factor, then you might as well use the quadratic formula in many cases. Okay, so we want two numbers that multiply to -15 and add to -2. Think about that. They're going to be, bigger number has to be negative, so -5 and +3. So now we've made it into two numbers multiplying together give us 0. So either this number has to be 0 or this number has to be 0. Solve these little mini equations and we get that x can either be 5 or -3. So again, two exact solutions that happen to be integers. Okay, D. So this one looks a little different. There isn't 3 terms. They're all onto the one side though. But if we follow our factoring flowchart, is there a common factor? Yes, and the common factor is 2x. Okay, so 2 goes into both terms, but there's also an x in both terms. So then to common factor again, you're going to mentally divide each of these terms by 2x. So 2x squared divided by 2x is x. -6x divided by 2x is -3. So this one's a little bit different. So instead of 2 things multiplying together, you've got 3. So you've got the number 2 multiplying by the number x, multiplying by the number x minus 3 is giving you 0. So multiplying by 2 isn't going to affect my answer at all. Okay, so, but multiplying by x, so here's my second one here. So 2 can't change to be 0. 2 is a constant, in other words, so kind of doesn't help me figuring out what x could be to make the solution true. So 2 times x, so 2 times some number, you could think of it as a, or sorry, you can think of it as 2 times a times b equals 0. Okay, so 2 isn't going to affect it. This number a is the number x, and b is the number x minus 3. So this one, if you look at it, it's already solved. X is 0. So think about that. 2 times 0 times 0 minus 3 would be 0. So x equals 0 is a solution. And here I would have to add 3 on both sides. So x equals 3 is also a solution. So again, we got 2 solutions, 2 exact solutions, 0 and 3. Okay, maybe put a little star beside this one. A lot of people forget about common factoring. All right. Next question. All right, so again, we have to get everything to one side. So subtract 5x. It's not common with anything here, but we know we want to have it with the 2x squared, then our x term, then our constant equals 0. So if you're looking at your factoring flow chart, there's no common factor. There's 3 terms, so it's a trinomial, but this time it's a complex trinomial, because the number in front of the x squared is not a 1, it's a 2. So to factor a complex trinomial, we'll use decomposition. I'm going to show you this. Some people would probably prefer to use the quadratic formula at this point, and that's perfectly fine. But I do want to show you that if it's a factorable trinomial, even if it's complex, you can still solve by factoring. So for it to be factorable, you'd need 2 terms that multiply to negative 6x squared and add to negative 5x. So those would be negative 6x and positive 1x. So multiply to negative 6x squared, 2x squared times negative 3, and add up to negative 5x. So then you look at your 2 terms over here, and you say what has more in common with 2x squared, negative 6x or 1x? So negative 6x, because 2 goes into 6. Then the one that we didn't use, so plus 1x. And then our minus 3. So the reason it's called decomposition is we decompose this middle term into negative 6x and positive 1x. So now that we have 4 terms, we factor by grouping. So what's in common with 2x squared and 6x? 2x. And then divide each part by 2x. We would get x minus 3. Sign that goes next comes next. What's in common with 1x and 3? 1. Then we have this binomial common factor. And if we divide each of these big chunks by x minus 3, the first chunk you get 2x. And if you divide the second chunk by x minus 3, you get plus 1. And now you've factored it using decomposition. So now we've changed it into that format, some number times another number equals 0. So that's going to lead to our 2 solutions. Either x minus 3 has to equal 0, or 2x plus 1 has to equal 0. This one's really easy. We know that x equals 3 is one of our solutions. And the next one's just 2 steps here. X equals negative 1/2 is our other solution. There are 2 exact solutions, an integer and a rational number, a negative fraction. And that means that if we were to sub 3 into our original, left side would equal right side, and same thing with negative 1/2. So it's the values of x that satisfy the quadratic equation. Okay. Recall from previous grades that to solve for the x-intercepts of a relationship. So anytime you're asked to find x-intercepts, we did this in grade 9 and again in grade 10. The rule is you always set y equal to 0 and solve for x. Set y equal to 0 and solve for x. So when you're finding an x-intercept, set y equal to 0 and solve for x. So applying solving quadratic equations to finding x-intercepts is very important for grade 12, and that's why we're going to review this concept, which you should hopefully have done in grade 10. So example 2, determine the x-intercepts of each quadratic function. And remember, quadratic function is a parabola. That's what it would look like if you were to draw a picture of it. So here's our first parabola, y equals x squared plus 6x plus 8. So we're going to use that rule then that to find the x-intercept, we set y equal to 0 and solve for x. So I'm going to set y equal to 0 and solve for x. So now I've got what looks like a quadratic equation like what I just had. If I want, I can turn it around so it looks even more like what we just did. And then see if this is factorable, and it will be, because it's applied to what we're learning today. So we've got a simple trinomial, and we need two numbers that multiply to 8 and add to 6. So 4 and 2. And then we get our two solutions. Either x plus 4 has to equal 0, or x plus 2 has to equal 0. And some of you will be able to go straight from x plus this step to straight to x equals -4 and x equals -2, and other people will prefer to show the steps. But those are the x-intercepts, or zeros. Okay, so another word for x-intercept is zeros, and that's probably the word that they're going to use in grade 12 of this parabola. So that means along the x-axis there would definitely be a point at -4. There's one x-intercept of the parabola, and another one at -2. So there's another x-intercept of the parabola. Okay. In this example, we'll go through and figure out how to draw the whole parabola, but that's not a big focus. It was a big focus in grade 10. More just being able to find the x-intercepts is what we want to do, but I do want to show you that it represents a parabola. We do know that the step number is a +1, and some people would just be able to use that fact and know that it opens upward as well, okay, to figure out that the vertex then should be right here, because the x-intercepts are only 2 apart. So that makes sense with the step number. If the vertex is here, over 1 up 1, over 1 up 3. But you can also find the vertex because we know that the axis of symmetry of a parabola is always halfway between the x-intercepts. So if I add the x-intercepts together and divide by 2, actually, no, I want vertex, sorry, here. So the x-coordinate of the vertex, which I'll call x-vertex, is going to be found by adding the two x-intercepts together and dividing by 2. Okay, and then you can see that that's going to give you -3, which you can see is right here. And then to get the corresponding y value that we could call y-vertex, you can sub -3 into our parabola. So we could put -3 in for x. And that's going to give you 9 minus 18 plus 8, which gives you -1. So we've figured out then that the vertex is -3, -1, which is what we kind of predicted when we knew the step number. And that step number being 1, we can continue on. So over 1 up 1, over 1 up 3, over 1 up 5, and we've got our nice parabola drawn in. Okay? Again, our focus is just to be able to figure out the x-intercepts, but there's a throwback to grade 10. If you know the x-intercepts of the parabola, you can find out the vertex by averaging the x-intercepts to get the x-coordinate of the vertex, and then substituting that number into your equation to get the corresponding y value of the vertex. Okay, B. So we want to determine the x-intercepts of this parabola or quadratic function. Okay, so again, to get the x-intercepts, you set y equal to 0. And solve for x. A lot of people like to turn it around so that 0 is on the right side. Then we want to look on the left side and see what type of factoring is involved. Again, we have a simple trinomial, so we need numbers that multiply to -6 and add to +1 in this case. So those numbers are going to be 3 and -2. multiply to -6, add to +1. And we've got our x-intercepts. Okay, so now you can notice that I didn't put the squares in here because we really want to focus on, finding the x-intercepts here. So we've got an x-intercept at 2. So I'm just going to put some tick marks. There would be my x-intercept at +2. And here's one at -3. Okay, and we know that our A number is +1, so our vertex is going to be halfway between -3 and +2. So that's at -0.5, somewhere along here. It doesn't really matter. I just want you to draw a parabola that opens up, like sketch a parabola. We're not too worried about where the vertex is, just that we know where the x-intercepts are. Okay? All right. And that this one opens upward for sure. If I wanted to know where that was, again, you could do it using math. Average the x-intercepts, or you can type it in to Desmos. So I've got Desmos here. Y equals x² plus x minus 6. And you can see if you click on there, it tells you that the parabola or the vertex is at -0.5 and -6.25. Just to make sure that and then here you can check your intercepts, 2, 0, which we got, and -3, 0, which we got. All right, next one. Here maybe I'll do a little therefore statement. So therefore the x-intercepts are -3 and 2. Okay, and remember these are also called zeros. Okay, C. So x-intercept set y equal to 0. And solve for x. Okay. This one, because the step number is negative, which will come back later when we do our sketch, but to make it easier to factor, maybe we want to rearrange it by adding x² to both sides, adding 2x to both sides, and subtracting 15. And then instead of just turning it around, we've made it easier for ourselves to factor. Okay, so now we've got a simple trinomial again with a +1 in front rather than having to deal with a common factor of -1. Since we're only focused on finding the x-intercepts, that's fine. So we need two numbers that multiply to -15 and add to +2. So it's going to be +5 and -3. So we've determined that the x-intercepts for this parabola are at -5 and +3. So here's +3, -5 here, and our vertex is going to be halfway between -5 and -3, which is so if you wanted to figure that out, just mentally add them together and divide by 2. So we know that our vertex is going to be along -1. Okay, remember it's not important that you're able to find the vertex, but that you're able to find the x-intercepts. But we do know that we have a negative parabola, So our parabola is going to be going to a maximum. Doesn't look very good, but we got our x-intercepts. And then again, if you want to check on Desmos, we can type this one in. So, should we got my screen there? So negative x squared, y equals negative x squared minus 2x plus 15. And we have to bring down, so we can see that our vertex is up at, click on that, -1 and 16. And our, oh wait, did I type it in right? And our intercepts are at 3, 0 and -5, 0, which is what we found. Okay? All right, next one, D. Y equals 2x squared minus 8x plus 0. Again, to find an x-intercepts, we set y equal to 0. Turn it around. Now in this case, we see our, if we look just back at the parabola up here, our step number is 2. But when we get to here and we're looking at our factoring flowchart, the first thing it says to do is check for common factors first. So in this case, we notice that 2 is in common with all 3 of these. So we can common factor 2 out. And then what's left inside the brackets can be factored because we're left with a simple trinomial inside the brackets. So that simple trinomial, we need 2 numbers that multiply to +3 and add to -4. So that's going to be -3 and -1. So when we're multiplying to a positive but adding to a negative, both numbers have to be negative. Okay, the 2 never equals 0, so we have 3 numbers multiplying together to get 0. One of these 2 is going to have to be 0. Because 2 is a constant and it's always going to stay 2. So we've got our x-intercepts. Our x-intercepts are 3 and 1, both positive. So at 1, there's an x-intercept, and at 3, there's an x-intercept. And we've got a positive step number of 2, so easy to see here that our vertex is going to be along x equals 2, and we know we're opening upward. So there's a little sketch of our parabola. We can come back to Desmos, type it in, check our answer. Y equals 2x squared minus 8x plus 6. And there we go. We've got our 2, -2 would have been our vertex, an x-intercept at 1, 0, and an x-intercept at 3, 0. Okay, and E, find the x-intercepts. I'm using function notation, which is fine. So for x-intercepts, y equals 0, or instead of saying y equals 0, we can say f at x equals 0. They're using function notation. Okay, we can switch it around. Factoring, so 2 numbers that multiply to +25 and add to 10, they both end up being 5. Or we can write it like this because it was a perfect square trinomial. So this number x plus 5 squared equals 0, and the only way for that to be true is if x plus 5 equals 0, 0 squared. And the only way that's true is if x is negative 5. So we only end up getting one x-intercept. Only one. If it's a parabola and there's only one x-intercept, that means the x-intercept must be the vertex. So there's only one x-intercept, it's at negative 5, but we know it's a parabola, which means the x-intercept must be the vertex. It's got a positive 1 for a step number, so it's going to be opening upwards. So that's what we expect it to look like. We can try it out here. So y equals x squared plus 10x plus 25. And there we go. We click on our vertex there, we can see it's at negative 5, 0, which is what we predicted. Awesome. Okay, and then why did we review this? Why is this so important for grade 12? So here's a little preview, okay? So in grade 12, you'll get a question like this. Determine the x-intercepts of the function y equals x cubed. So you'll start in grade 12 sketching a cubic function. And then if you take calculus, you'll learn how to find where the points in between are. Okay, but we can, just based on what we already know, we can use the fact that to find x-intercepts, you set y equal to 0 and solve for x. Maybe we want to turn it around. So you look at your factoring flowchart. Is there a common factor amongst all 4 terms? No. There's 4 terms, so you must be able to factor by grouping if this is factorable. So let's see if we can factor by grouping. So what's in common with the first 2 terms? X squared. So if x cubed divided by x squared is x. 5x squared divided by x squared is 5. Sign that comes next goes next. What's in common with 4x and 20? 4. So you're dividing negative 4x by negative 4, and that gives you x. Careful, positive 20 divided by negative 4 is negative 5. And then if you look at these 2 big chunks here, they've got the binomial x minus 5 in common. And then divide each chunk by x minus 5, and you'll get left with x squared minus 4 equals 0. But to fully factor this, if we've got a squared factor, we want to see if it can be factored. And if you look at your factoring flowchart, there's no common factor with x squared minus 4. There's 2 terms, so either it's a difference of squares or it can't be factored. In this case, it is a difference of squares. So which factors to give you x plus 2 times x minus 2. And now we've got this idea, 3 different unknown numbers multiplying together to equal 0. So just do my thinking up here. A times B times C equals 0. And A, B, or C have to be 0 for that to be true. So we can set each factor equal to 0. So we have x equals 5, x equals 2, oh, x equals negative 2, my bad here, and x equals positive 2. So therefore x-intercepts, or zeros, are negative 2, 2, and 5. 1, 2, 3, 4, 5, 6, say negative 1, negative 2, negative 3, negative 4, negative 5. So we're thinking there's an x-intercept at negative 2, another one at 2, and another one at 5. And how are these joined? Well, for polynomial functions like this, that they're smooth curves, and you'll learn a lot more about this next year, but it's going to be something like this. Oops. But we can look on Desmos again. And type it in. So we have y equals x cubed x cubed, there we go, minus 5x squared minus 4x plus 20. And we can see how that looks. And we can look at our intercepts. Negative 2, 0, which we found, 2, 0, and 5, 0. And then, as I said, in advanced functions or in calculus, we'll be able to find what these points are. Okay, so that's just a little preview of why it's important to be able to use factoring, or the quadratic formula. It would take a bit longer, but once you've got it down to this level next year, this one's easy to find. If you weren't able to factor x squared minus 4, you could always use the quadratic formula to figure out the roots as well. Okay, so just a little preview. Okay.